example 2 is what we're going to start with. Oh, okay, got it. Did you have a homework packet? There's 2 separate packets. Okay, so that's what I thought. So on the back there, the 2 different piles are separate things. That's the notes. The other packet is just homework. Oh. Uh-oh.
Yes, I was very sad.
Supposed to.
First test is class.
Sofa might not do it.
Oh, okay.
Well, for the record, my test was I thought I was gonna ace it. Yeah. What do you Like, it didn't make sense. I thought I was gonna do so good. And then I got.
Okay, good. We're recording. So, these are pretty much standard problems that are in every textbook. I'm unsure why, but virtually every calc textbook has the same type of related rate questions. The main thing that changes is the shape. So, this first one here, it uses strange wording, but it's very specific. Okay, so somebody drops something into calm water, which you guys have all done that before, to be honest. Virtually everybody has either done that in a bathtub or a sink, even if you've never done it in a lake. So when you drop something into calm water, the initial splash creates a circle that goes outward, and then the water that goes up and down from the initial splash, basically trying to equalize itself, creates little circles that go outward. They call those concentric circles because they're circles within circles. So if you drop something in water and you actually take the time to watch it, dropping something in causes the water to go up and down. The water going up and down creates the waves that go outward in a perfect circle. The circles / waves that are going outward go at an even rate. And so next time you do that, it's easier to watch in a lake. Like if you've got a really perfectly still lake and you throw a rock way out there, it's much easier to watch that. But it still works in a bathtub or sink. So this one says, a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple, which, FYI, it doesn't matter which ripple it is, they're all going to be the same. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. So when you drop something in the water, it's easiest to watch the first wave or the outside circle, just because you can see it moving easier. So if you are watching the outer ring of this circle get bigger, this says it is moving outward at 1 foot per second. It doesn't change from 1 foot per second. When the radius is 4 feet, I don't know, but this is roughly 4 feet, right? So when the radius is 4 feet, it wants to know how fast the area is changing. If you have a very small circle, and this small circle goes 1 foot bigger, 1 foot per second bigger, well, the area didn't change much because it was very little to start with, and the circle that you added was also small. But if you have a 4 foot circle, like this would be the radius, like that's a relatively large circle. And adding 1 foot onto a large circle may not look very big, but that's actually a lot of area that's changing. So it wants to know what's the rate of change of the area at the 4 foot mark. So these questions, where most people get confused, well, it's a lot of information and you're trying to picture it all in your head. first thing I would recommend you do is write down exactly what you are trying to find. Actually, I have a perfect job for you.
That's an honor.
I thought you already did this. You already got it written down.
Yeah.
So this is perfect.
Okay.
They all have a lot of stuff to write down. Who's gonna go first?
Oh. 23.
I mean, you don't have to do any math, but
27.
27. I think it's back there. Excellent. What are we trying to find? What does it ask us to find?
The area when the radius is 4 feet.
Close.
The rate of the area.
Yes. It's asking us to find the rate of the area changing. The word rate should tell us it's the derivative. Okay? How do I write? I don't know the best way to phrase this. How do I write the derivative of area?
For circle.
A prime is technically correct, but we need to use the notation that fits what we were doing yesterday.
So dA over dt.
Perfect. A prime is absolutely correct, but we need to write it as dA dt. You want to. Okay, write it as A prime. So this is the one thing that when we are done with this problem, we wanted to say dA dt equals a number. dA dt should kind of directly tell us that we're going to be needing an area formula. Because if we take the derivative of a volume formula, you're not going to have A anywhere in it. So dA dt should tell us that we need an area formula. It doesn't tell us any formulas. So we have to use these clues. What's the shape it's talking about?
Circle.
Okay, so area of a circle. Hopefully you know it. If you don't, look it up. So pi r squared. And then because we are trying to find A prime or dA dt, we need to take the derivative of this formula. So we're basically just doing the stuff that we know, and then we will start filling it in as we get along the way. Like, I'm just kind of going by what it asks us to find. I am 100% ignoring this information on the left. Well, now you got me thinking. I'm trying to decide if there's any advantage to writing this notation over A prime, but I felt like there was. Maybe it won't matter. I'm gonna keep writing it this way regardless, but if this notation does really confuse you, I mean, I guess it shouldn't matter. AP won't mark you wrong if you write A prime instead of dA dt. You are allowed to write prime as notation. I've always felt like this made more sense because it helped me know which letters I needed to use. Like if you write A prime, you don't know it's times rather than X, but I don't know, that's just a minor detail, I guess. Derivative of pi r squared. Who's gonna help me with that? Oh, you can roll it a whole bunch of times if you just haven't backed up. 18, or you can make noise. You can make noise.
Oh, yeah.
18. So we're here. What's the derivative of pi r squared? I can't remember if we did this one yesterday. I don't think we did. I think we did 2 pi r yesterday.
2 pi. No, 2
I can give you some guidance if you want.
is it 2 r times r prime?
Yep. The pi is a number multiplier, so it has nothing to do with the derivative. And so we would write pi times 2r, r prime. And it's not wrong if you write 2 pi r prime, because I think you started saying that first. They're both correct. You basically can just do the power rule because this is a number multiplier. Okay, so this is the differential equation, which means the derivative. Okay, I've got stuff up top that I'm supposed to plug in.
Um, 60.
If I read through this sentence, I basically only see 2 numbers. So those are my 2 numbers. Where are they going to go in place of?
The,
This one should be semi-obvious.
yeah, the R.
R, correct. Radius is 4 feet is directly telling us R is 4. Now, if you want to include the label, you can. It's kind of iffy if AP is particular about that, because sometimes they are and sometimes they're not. For right now, I'm not going to do labeling because I would rather focus on the problem. As you get better at these problems, I'll do more of the labels. Okay, so the radius is 4 feet. What is 1 foot per second? Like, what is changing though? So it tells us specifically what's changing.
The distance.
Um,
Oh, the radius.
Yeah, I suppose my highlighting probably would have helped if I don't know if I need the, but,
The radius.
yeah. The radius is changing at 1 foot per second. So the label for the radius changing, basically the word change always refers to a derivative. This is dr dt. If it has the per second, that's automatically going to be a derivative of some sort. Over here, the radius was 4 feet. It just directly had feet, did not have any type of a time associated with it. The time makes it a derivative. Okay, so dA dt is what I actually want to find, so that should stay in the equation. Everything else should be filled in. So R was 4 feet. dr dt was 1. Actually, you know what? I changed my mind. I will be putting labels in. Because I was going to say the answer when you're done absolutely has to have a label. So 4 feet times 1 foot per second. When we multiply that all out, we're going to have 8 pi feet squared per second. So the labels in a problem should theoretically give you the exact label you need at the end. Like area, I knew area should have been square feet. Per time would mean per second, per minute, whatever. So I knew the label should have been square feet per second. And during the problem, I got that from the labeling that was there. So that kind of like is a check for yourself. I don't know, how's that one so far? This is basically the idea of what we do for every one of these problems. We're going to write down what we're asked to find. This generally is a clue to let us know what type of equation we're going to do. Or within the problem, there's going to be wording telling us the shape. So the shape basically only has a couple options. A circle, we really only had a couple options on circle. We have area of a circle or circumference of a circle. It's kind of it. And so within the problem, it mentioned area, so we went with area formula. Okay, I think the one below is the balloon, isn't it? Yeah. Our goal is to be getting as many of these done as we can today. The homework I put the homework due by Friday at 3:06 PM. Actually, I can't remember if I put the time. I know I did not put Friday night because I wasn't going to check Friday night. And for your sake, I knew that you weren't gonna wanna do any homework over break. So I put the homework due Friday, right at the end of the day. Cause I thought that would be your best bet to get it done. Cause nobody's gonna wanna do any over break. If you would like to do it over break, you can. I'm not gonna mark it late. I'm just telling you guys right now that you don't want to. If you put this off until January 4th or whatever it is, you're not gonna remember a thing. So you want to try to get it done by Friday if you can, but I get that you might have like 5 tests or something Friday, I don't know. So whatever your schedule you have, just do whatever. I'm not gonna remove points if you don't get it done by Friday. For your sake, I'm trying to tell you to get it done by Friday. Okay. I mean, I can roll if you want. Lena, what is it asking us to find?
How fast the radius of the wheel is changing.
Okay, the word fast is telling us the rate. So the word fast implies derivative. So this is asking us to find the derivative of the radius. Or, I mean, I guess it even says the word changing, but it's asking us to find the change in the radius. Now, radius implies it's a circle of some sort, and so there's not a lot of options, but it tells us a sphere. And in the problem, I believe it mentioned a volume, 800 cubic centimeters. So the clues in the problem are telling us volume, circular, so that would be a volume of the sphere. If you don't know volume of the sphere, look it up, but you're gonna have to know it eventually. 4/3 pi r cubed. I understand and get that you haven't used that formula forever. You probably haven't used it since geometry. Yeah, I get it. I'm not the one that rates the AP test. I'm just gonna let you know what you need to know for the test. I am still a firm believer that you should get a formula sheet for the AP test. Okay, volume is 4/3 pi r cubed. We need dr dt, which tells us we have to find the derivative. So let's have somebody tell me how to do the derivative, hopefully. 8, one of you. Tyler, are you 8? Okay,
Yeah.
derivative.
So that'd be 4/3 pi. I'm just solving it really quick. So.
Tell me what to write.
Okay, let me just do it real quick.
That's a good idea.
Yeah, I got 4/3 pi times 3r squared times dr dt. You guys right? Nope.
It may be correct. You just flat out ignored the left-hand side.
Oh, dr dt equals.
dv dt. R is over there. We can solve for dr dt at some point.
You're right,
Yeah, yeah. So we can solve for dr dt. We don't need to right away.
Yep.
So dv dt, and then, I know I heard you say 4/3 pi.
Pi, yep. And then it should be 3r squared times dr dt.
Yeah, no, that's correct. So if you would like to solve for dr dt right here, you can. If you want to solve for dr dt at the end of the problem, you can. It doesn't actually matter when you solve for it.
Should I tell you dr dt?
Like the answer?
Yeah.
No. I mean, it's cool if you know it already, but we're doing it. Our next step is basically put in information that it tells us that we know. I should really get some sort of electronic picker, like, so I can just tap a button. No, but, okay.
That's 1.
1? I thought you were gonna say 8. All right. Do you have headphones on? It's hard to hide those. Are you basically just watching this but listening to something else?
No, I think no, because.
Oh, why are you wearing headphones then? Okay, so what I was hoping you could tell me is what information does the problem tell us to be able to put into the equation? Okay, so what does the 800 stand for? Like what is the label? Which one of these is 800? Okay, thank you. So the cubic centimeters you said was correct. But the fact that it says per minute would mean volume per time. So this is dV/dt. And then there's one other number, the 30. Yeah. It says the radius is 30. What the heck? Perfect. Now that's all we need for this one because there's not that many letters. We needed dV/dt, and we needed R. That one should be blank. And so you can rearrange the formula first or last, doesn't matter. I'm just gonna put all the numbers in first. 800 cubic centimeters per minute. 4/3 pi times 3 is 4 pi. R squared is going to be 30 squared. The 30 is 30 centimeters. So that'll actually turn into square centimeters. dr/dt is what we want for the end of the problem. Okay, so we have 800 cubic centimeters divided by 4 pi times 30 squared is going to be 4 pi times 900, which is going to be 3600 pi square centimeters.
Where did the 4/3 go?
Cubic centimeters per minute divided by centimeters squared would reduce down to regular centimeters per minute, which is perfect because that's what dr/dt should be labeled. This is going to be I was thinking 3200. So the zeros cancel. 4, 18, 2 ninths. 2 over 9 pi. That's a dumb answer, but whatever. 2 over 9 pi centimeters per minute. If you want to change that to a decimal, you probably can. I would expect this question probably would have been, well, I don't know. I mean, nobody knows what 2 over 9 pi is, so we'll go with it.
Where'd you get, 3600?
4 pi times 30 squared.
Put that in my calculator.
Calculator?
Huh?
What calculator? What are you guys doing? 30 squared is going to be 9 with 2 zeros, 900, times 4, 36, 2 zeros, pi. You're not actually going to multiply by pi. Like,
Oh, yeah, that's right.
if this was a calculator question, then it generally will tell you in the problem to use 3.14 for pi. So in that case, this would just be a decimal. Like this is a stupid answer. Nobody knows what that is, but that's what it asked for. This would definitely be a non-calculator question on the AP test. Oh, no, these are actually still better than the AP test. They are dumb things. Like, nobody knows what 2 over 9 pi is. Everybody in their head makes it a decimal. It's like radians. Everybody in their head does 30 degrees, 60 degrees, 45 degrees. Doesn't matter, that's just how your brain works. Okay, let's do one more. Do you guys think you could try this one on your own? Or would you like me to, draw?
The letters sliding down the vertical.
Should I, this was the one I was telling you about yesterday, the ladder, falling off a wall, but, you know, like, nobody actually does that. I'll help you draw it, how's that? 25-foot ladder. 25 foot means it is never changing size. Even though ladders generally are changeable, this one is telling you the ladder will always be 25 feet. And apparently the person didn't set it up very good because it's falling out. Wall, ladder, ground. Here, I'll just draw a graph. We're sliding down a vertical wall, constant rate of 3 feet per minute. So it is going downwards at 3 feet per minute. When the ladder is 7 feet from the ground, so this is 7 feet, what is the rate of change of the distance between the bottom of the ladder and the wall? The rate of change of distance from the bottom of the ladder and the wall would mean, how fast is it going out that way? Okay, now, the main question you're gonna have on this one to start with, Debbie, get off your phone. I get that you have multiple things going on, apparently. This one is gonna be ridiculously hard if you don't try to concentrate on it. The tip I will tell you. No, I want to give you a couple minutes to try it on your own first, before I tell you anything, because that's how these problems go. It's problem solving. We'll do it together because we got time. Yeah, we get done at 2:05. We'll have plenty of time to finish this one together, but I want you guys to try to see if you can figure out what to do with it. First thing you should write down, what are you trying to find? Then you try to figure out what formula am I using. Take the derivative of it, plug things in. What? What's the fifth one? Oh, that's all right.
So X squared plus
Wait, what did she say?
They're trying to cheat off you.
It's on the formula sheet we had.
In college, you would have to pay her or bribe her to get that info. Like, people literally charge you for tutoring services at college. Like, the people in your class. So, the better you guys are at Calc 1, the more money you'll make at college.
What if I don't take Calc 1?
No, you're gonna wanna take Calc 1 at college, because you'll know how to do it. This is Calc 1.
I don't want to take Calc 1, that's not hard.
Wait, why are you taking Calc here?
The next one in college credit.
Why didn't you take CIS math modeling then? That's college credit too.
I mean, you said this was free, right? You don't have to pay for Calc 1.
Oh, 100%. It's also a nice easy grade when you get to college. The AP test here doesn't have to stand for Calc AB. It can just stand for a math credit. You don't have to use it for Calc.
Why couldn't I take like AP algebra?
If there was a class, you could. But that's AP pre-calc. That's going to be a math credit. That'll just be a math credit at your college. Yeah.
Yeah, I know that.
Well, then that's the formula.
1/2
25 squared.
height side.
Okay. Yeah. Well, you stopped because you had an answer of 0? But that was right.
What is the rate of change?
Wait, this one? That wasn't good enough? Yeah, but she was sick at this part. You can take it. Oh.
Yeah, I
He just
hate
got
those.
a clip in the back part.
How fast is it full?
They said, well, what's the velocity to the impact of the magical mountain?
I mean, that's true, but the mathematician wouldn't help on that.
The mathematician would be that.
That would be the scientist who's gonna be doctor. Mathematicians have to how long it falls, what speed it
That's
lands.
why mathematicians don't get paid.
Not sure, we actually get paid.
I'm doing it.
No, not a math teacher,
Okay, I'm
mathematician,
Doing what?
actuary. An actuary calculates for companies. I mean, starting salary is like $100,000.
That's it?
Starting salary?
I gotta call it.
Okay, starting teacher salary is like 30.
Yeah.
How much do you think you're gonna make at this job?
My starting salary is what I wanted to
It
do.
needs some salt and pepper.
How good luck with that? Oh, that's true, but that also has like 10 years of school.
No, only 6.
Sounds like it. Okay, that's okay.
I don't know how to do that.
What?
What's the flow?
About what? I got nothing for you, I don't know what you're talking about. Talking about light, that's a very different question. This topic, we're learning how things change. You wanna go into pharmacy,
I'm never gonna use it again.
100% not true.
Why else would I? Yeah, I would need to know the rate of change.
You are going to be talking about comparing drugs, how fast they are absorbed into the body, and using them in different purposes. Pharmacies use it a lot. I mean, are you going to be trying to calculate how fast a ladder goes off the wall? No.
Why would I care?
Because this is easier to figure out at first. Shut up your phone. You're like 8 feet away. Talk to each other. It is weird. Without question. Okay, that's pretty much doing the whole beginnings for you. So what I wrote in green was what was given. And I know you haven't done many of these, so even just translating what it tells us is not easy for you yet. So what was green was what given to us.
Wait, so it was the Pythagorean theorem?
So you have a triangle. I was going to say, I'm trying to explain this and I can't talk over you right now. You guys are the ones that asked me to explain it. Shush. There is only so many formulas that refer to a triangle. So you can have area of a triangle, you can have circumference, which is what everybody figured out was Pythagorean theorem. Like, there is only so many things you can do with a triangle. Like, you can't calculate that many things. So, this has nothing to do with area. Nowhere in the problem did it say anything about area. It only mentioned lengths. So, if lengths is the only thing that's being talked about, it has to deal with the side lengths of that triangle. So that's Pythagorean theorem. You can label them whatever you want. You can label them A, B, C. You can label them X, Y. I don't know, what do you usually label it? D for why can't I think of the word? The hypotenuse, diagonal, whatever, yeah. I was gonna say diagonal, but, it doesn't matter what you label them. The 25 doesn't ever change, so I didn't put a letter on there because it's not variable. A letter refers to the fact that the numbers change. Because the 25-foot ladder never changes, I didn't put a letter on there, otherwise I would. It mentioned that the ladder was going downwards 3 feet per second, minute. 3 feet per minute. That's a weird, whatever. It's going downwards, so that is a negative value. So it's actually a -3. The ladder is sliding that way. That way would be a positive number. So when we are done, the answer should be positive. It told us it mentioned that it was 7 feet from the bottom of the wall, or top of the wall, or whatever. 7 feet from the ground. So at that moment, this is 7. We can calculate this length at that moment by Pythagorean theorem. So, 24? Is it really 24?
Yeah.
Okay, these numbers make 0 sense, but that's okay. If that ladder was 24 feet away and only 7 feet up, it would never even be off the ground. No, if you were on that ladder and it was sliding down, and it was 24 feet out, that ladder would have already fallen. That's what I meant, We can make up any number. So now I'm just gonna plug in all this info. This was the only remaining number we needed. So 2 times 24 feet. Go for it. dxdt is what we're finding. It doesn't save me time. 2, 7 feet. It's okay if it saves you time, it doesn't save me time. I wasn't mad that you said you do it. Go ahead, ask it out loud.
Why is X on your triangle? Why is X that way and Y this way?
Why is it the other way?
Oh, yeah. That is a great question.
'Cause like, you get a,
No, you are 100% correct. I tried writing it that way. I even put the correct numbers over here. I just had them written backwards over there.
yeah.
No, good catch, because that would have probably confused somebody who looked at it later. Oh, and then over here is still 0. 0. Yeah, I put the correct numbers up here for X and Y, and I wrote them backwards without even knowing it. So I've got 48. I need to bring that one over, 14 times 3, 42. So on the right-hand side, I would have 42 feet squared per minute. Because if I add it to that side, it'll be positive. On the left-hand side, I would have 48 feet times dx dt. I don't have enough space to write all the steps, but I multiplied that out and then added it to both sides. I will divide by 48 feet. Dx dt would be 42 divided by 40. 7/8? No. Yeah. 7/8 feet per minute. Another strange answer, but that's okay. Especially per minute. Now, FYI, if this were actually kind of realistic, the ladder sliding down the wall would not be a single number. It would slide down slower at first and a lot faster at the bottom. So that would definitely be variable, but for the purpose of trying to practice a problem, just numbers were thrown in. But realistically, that wouldn't happen, so this would be a more complicated problem. Okay. The main thing you guys need help on. Like, are you having trouble figuring out where numbers should go? You having trouble figuring out what formulas, like, that's what I'd like to try to help you with. The more of these we do together, the more comfortable you'll be, but as you can see, they go super slow. What I would like you guys to do, if you can, do not look up the answer key to the notes. Hopefully, they're not already open on multiple Chromebooks that are open. It's not like it's a bad thing, right? It's not a bad thing to look at the answer key to the notes. The reason I was saying is, I was wanting you to try to draw number 5. Because the hardest part I've seen from students in the past is even knowing what this one says. This will be the first one we do tomorrow, but we have 10 minutes left today. I want you guys to see if you can draw the picture, and then you are welcome to go look at the answer key to see if you drew it correct. But that way you can at least have the picture drawn, so that tomorrow we can do this one first. And then tomorrow's a shortened hour, so we'll do this question, and then I will do a question, I think the next page is the one with the shadow. Like, there's a light pole, and then the shadow's changing. So that one I'll try to do with you tomorrow, just to show you different kinds of problems. No, I bet you the next page is the cone.
Did you?
Either way, we'll see what we can fit in. Today, just try to draw this picture. If you want to try to start some of the homework questions tonight, I guarantee you could do the ones that are similar to what we've done together. Because the homework questions are going to kind of match up. Not perfectly, but kind of. 1 through 6?
That's what we did.
That's what you did. I'm just giving them everything. Yeah. No, yeah, you guys do as much of the homework as you can, because your goal is to try to get it all done by Friday afternoon.
That's